Okay, back on the Soundesign CD player, and even though I forgot to show it or mention it in the first video, I indeed cleaned the laser lens, and of course many people mentioned that, and I failed to mention that I had done it, but that did no good. Even did it a second time just to be on the safe side, and it still didn't do any good. So this is what it does when we turn it on with no CD. It comes up and flashes for a few seconds, and that's that. Now let's put a CD in and see what happens. So we turn it on, and it does the same thing, and it makes no effort to spin. Now before, if I kept playing with it, it would sometimes spin up and tell me how many tracks were on the disc, but that was as much as I could get out of it. Okay, here we are exposed again. The next thing we're going to do is take our ohm meter and check these switches here. This one here, and there's one on the front that on the plastic front that we need to check. Okay, let's see if we can get anything out of this laser. A very little bit. As you can see, when I close the switch here, I see a little illumination, but not much. Really need to get this in a darkened area to really check it. And it looks like this sled sensor switch is open based on my continuity test, so I'm going to get some contact cleaner and try to get some down in there, and maybe this thing will make contact again, because if not, I don't know where we'd ever find a switch like that. I found a spring rolling around in the bottom of the unit. I don't know where that goes, but that could be part of our problem, maybe. Okay, the switch now has continuity, so let's see if it makes any effort to do anything. No, it does not. That laser, I think, would light up kind of very bright whitish blue, but all I'm getting is I'm getting a very faint orange glow, and that's it. Okay, even though they don't look too bad, I'm going to clean the contacts on this ribbon cable plug here. I don't think it's going to do any good, because I'm really thinking we have a bad laser pickup, and I know some of these have a potentiometer on them to adjust the power, but I do not see that on this particular pickup, so maybe it's on the board somewhere, but I don't like tweaking potentiometers that I don't know what they do, because when you got a machine that's already messed up, turning stuff without the proper equipment to align it with and the proper service information could get you into so much trouble that it may never work again. Oh, and one thing about these lasers, which I'm sure everybody knows, but it's worth mentioning, don't look at one of these with the naked eye, because it could damage your eyesight. Alright, let's see what we got. Same thing as we had before, just a little light, and that's it. Oh, come on and focus. So it's only going to go from bad to worse. They say the third time's a charm. Let's see. Well, not in this case, I don't get it. Oh, just forget it. Okay, here we have a box of parts from a realistic CD player that a gentleman sent me. It's one that he purchased off of eBay, and what happened is what happens with a lot of poorly packed stuff, and it got cream puffed, and the seller refunded him and told him to do whatever with it. So since it was physically trashed, he just pulled it apart and sent the inner workings to me. Figured I might could use them, so let's see if by chance this laser pickup looks like anything we can use. Well, unfortunately this one looks a good bit different than what we need, but it was worth looking at anyway. And as you can see, this one actually has the adjustment pot on the circuit board there for the laser power, which my unit doesn't have. As far as the spring, I have no idea where it goes, so I'm just going to throw it in the bottom of the unit where I found it, and this is going back together, and unless I can find something laser, this is probably going to the junk pile. And there are some CD players like this on eBay for ludicrous prices, like in the $200 range, which is nuts, and that's getting to be what eBay is turning into, the land of overpriced crap, just waiting on some sucker with more money than they got sense to come along and buy the thing. And of course, the only way to know what these pots do would be to obtain a service manual, and finding a service manual on a Soundesign CD player, good luck. The only way I might find something is if I knew who I OEM'd this unit and could find the service manual for another brand of this, but Soundesign, no. Now, I will say this CD player is built better than the Soundesign stereo that these were mostly sold to be paired with, and these CD players probably cost about as much, if not more, than the rest of the stereo did, so that's probably why you don't see too many of these. Most people buying those cheap $100 stereos were just listening to records and cassettes, and you know, they weren't going to go spend $129 on an add-on CD player to go with it. When they decided to listen to CDs, they just went and bought a whole better stereo with a CD player built in it in the first place. And now we'll get into something that is more of my element. This is a Perma-Power battery eliminator. Provides 1.5 volts and 90 volts, and was meant to be used with a battery-operated farm radio like what was made from the late 30s through the early 50s. These, of course, allowed said radio to operate on standard 110 volt AC power. So let's open it up and see what we got. This one looks in decent cosmetic shape. I've seen some that were pretty ragged, but this one looks pretty good. Okay, this is the newer type from the late 40s with solid state rectification, as in selenium rectifiers. The older version of this used a copper oxide rectifier for the filament supply and a tube for the 90 volt rectification. Usually all these need is just capacitors and possibly the rectifiers replaced. They're usually not hard to work on. As long as the transformer and choke are good, then it should pretty much be an easy repair job. Assuming this capacitor is the original one, and I feel like it is, it's date stamped January 1950, so that's probably when this power supply was made. You know, back then they made accessories so you could use your older radios and such. Now when something becomes obsolete, oh no, you can't use that, you have to go buy a new one. Okay, high voltage winding, 67 volts and climbing. Yeah, that filter capacitor is reforming. Normally with a good capacitor and under no load, that should be about 150 volts there. So yeah, you can see that voltage climbing as the filter capacitor reforms. And the filament supply is 3.6 volts and climbing. There again, it's going to be higher than normal unloaded, but under the proper load it should read around 1.4 volts. So I think pretty much all this is going to need is caps. Okay, there are two distinct reasons that I know this filter capacitor is bad without even connecting this to a radio. The first reason is it's taking our B+ so long to come up. You see it's still gradually climbing. Well, that's because the capacitor is leaky, and as voltage is applied across it, it's reforming and trying to act normal, but it just can't never get there. The second reason I know this capacitor is bad is because whenever I unplug it, look how quickly it discharges. Now, this power supply has no load across it. So if these capacitors were 100% healthy, you'd see about 160 volt charge across those capacitors for an extended period of time, but what's happening here is this capacitor is starting to act more like a resistor than a capacitor. So when the power supply is disengaged, the capacitor is basically, or what's left of the capacitor is basically discharging through its own leakage resistance. The one thing to take note of about these old battery eliminators is they have basically no voltage regulation. You have a high voltage winding which is feeding AC into a half-wave selenium rectifier, which the output of that feeds a typical pi-type filter network which contains of two capacitors and a resistor in the center. Unloaded, you probably have, like I said, about 150, 160 volts, something like that. But with the load of the radio applied across it, that brings it down to about 90 volts that the radio wants to see. And then down here we have a slightly more complex filament supply. We're feeding a diode selenium full wave selenium rectifier network here, which also feeds a pi-type filter, except we use a filter choke in this application to get the ripple down, because on those filaments we need to see as clean of a DC voltage as possible. Now, there's no regulation here. The closest thing we have to regulation is taps on these windings. You place the plug in one position when using the power supply with radios that use 6 tubes, and that will give you about 1.5 volts. Or if you're using a set that uses 4 or 5 tubes, which in that case the current draw on the filament line will be lower, you put the plug in the other position to get your approximate 1.5 volts. And just like with the B plus supply up here, when this is unloaded, the filament supply is unloaded, it's going to measure higher on a voltmeter. And of course your output voltage is also somewhat dependent on the AC line input voltage. But yeah, I could rip this apart and rebuild it into a regulated supply, but these worked well enough back in the day in their original configuration, and they can still work in today's world. Now, one last thing before taking it down to the workbench, let's see how much AC we have across that main filter capacitor. Started out at 6, 5 volts and dropping, so yeah, that's just another factor of that capacitor trying to reform. But we do definitely have some AC ripple going on there. Alright, looking at the filament, we have 4 volts unloaded DC. Now AC 0.006, so that's not too terribly bad. I mean, those capacitors are not great, but they're in better shape than the one for the B plus supply. Now, I know many of you have probably already wet your pants because we're running this power supply directly from the AC line. I know in order to meet approval I need to have this connected to a variac, and I need to bring it up very slowly over a 48-hour time period to prevent frying this thing. But here I am just leaving it plugged into directly into the AC and watching the B plus voltage steadily climb. We're up to almost 107 volts now. Come on, flip it over, flip, 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 flip. Now, as far as these selenium rectifiers, I'll leave them alone unless a need arises that necessitates replacing them. Sometimes they can act funny. When placed under load, then their output will drop down to an unacceptable level, and that's because the internal resistance of them often increases as the rectifier gets old. But if I can leave them in here, I'd rather leave them in here rather than replacing them with a more efficient silicon diode that will give us more B plus voltage. Now normally the rule of thumb, like in a radio or TV or record player, is to go ahead and get rid of the selenium rectifiers, but since this is such a low current application, and as long as they work, I really don't see any reason to change them. A dual 40 microfarad section reading 2.6 for section 1 and 2.3 for section 2, so it's basically lost all of its capacity. Now on the old school tester, it registers nothing as far as capacitance. Now what about leakage? Yeah, with high voltage applied, it's showing leakage. And this 1.8K resistor is up to 2.3K, which is out of tolerance. We can replace it with a 1.5K. It should be okay, but with it being that high, that might reduce our B+ output, so let's just go ahead and change it while we're in here. Hello?
Michael from Dealer Servicing. Your file just came across my desk, and it looks like your vehicle may be at risk of For you to prevent your extended warranty from expiring, I am giving you a courtesy follow-up call before I close out your file. Please press 1 to speak to a specialist now, or press 2 to call for a job opportunity.
Hello, do I have a specialist on the line?
Important to us. Please stay on the line and you'll be transferred to the next available agent.
Yes, hello, this is Macy calling from the warranty division. Can you please verify the year, make, and the model of your vehicle so I can pull up your file?
Okay, it's a 1984 Tonka dump truck.
Do you have a car that will cover the year 2006 to 2019?
It's a 1984 Tonka dump truck with 600,000 miles on it.
Okay, thank you and have a good day.
Okay, new capacitors and resistor installed on the terminal strip. Let's see what we get. 139, 140 volts. Alright, let's kill the power and see how long it takes for the caps to discharge. If you'll notice, it's taken them much longer to discharge than what it took with that old leaky, worn out, dried out, expired capacitor in there. Okay, we're connected to a little RCA farm radio that I overhauled. You might remember it. It's the one that the volume pod had been replaced with the wrong thing, and I found one of the right value, but I had to put a toggle switch back here for the power. So let's plug our battery eliminator in its current state and see what it does with this radio. Alright, let's flip it on.
Jason Smith. Yes, well played.
Well, as you can hear, it's playing, but we have some hum, likely ripple on the filament supply line. Alright, let's make some voltage measurements and see what we're feeding the radio with right now. Alright, I'm running right at 100 volts on the B+ line, and that's within tolerance, so I'd say this selenium rectifier is healthy. And I reoriented my filament plug for the 4 and 5 tube sets. Okay, I'm running 1.3 volts, which that will probably go up a little bit whenever I change those filter caps in the filament line. Now that's about as low as I'd want to run the filament voltage, because sometimes, especially the oscillator and mixer tube, once that filament voltage drops below about 1.3, 1.2, it will stop oscillating. The rest of the stages in the radio will work, but that 1A7 tube just won't have enough emission at that point to oscillate, especially if it's a used tube. It's got a lot of hours on it. I'd like to get that filament voltage up to about 1.5, 1.6 if I could, so let's take this back down to the bench and go ahead and change out these caps and that ought to conclude the repair of this battery eliminator. Okay, here are the two capacitors, both 1500 microfarad at 3 volts. This one here is what, a Cornell Doublier, and this is one of the better quality aluminum cased capacitors. And this one here is one of your cheaper quality potted capacitors, like the kind that just dry out. Goodman. Now, why couldn't they have just used two Cornell Doublier higher quality capacitors? And no, I don't think this is a replacement. It looks very factory to me. And I can bet you which one of the two is in the worst shape. Probably this one right here on the left. Well, the one on the left is jumping around all over the place. 6 something to 5 something. It jumped up to 7 one time. So that's pretty wild. And this one keeps jumping around. I'm on the 2000 scale, and it's acting like it's over that amount. It tries to go under sometimes, but this capacitor is probably leaky and making this meter think that it's more than what it really is. But in all reality, neither one of these capacitors are too good, so let's get rid of them. In a modern day 1500 at 63 volts is much smaller than a 70-year-old 1500 at 3 volts. That's just how much smaller they've got. Okay, here are the new low voltage filters. Negative end soldered to the this heavy-duty bus bar here. And I chose to J-hook the positive terminals on the capacitor to the existing leads that are soldered to the filter choke. The reason being is because sometimes these terminals on these filter chokes are extremely fragile. I go unsoldering them and yanking on wires, trying to get everything loose so I can make it look ultra neat, and I end up breaking one of the terminals off of the filter choke and breaking the wire off of the terminal, the internal wire coming out of the filter choke. Then we got a problem. So I'd rather sacrifice a slight bit of neatness over potentially ruining a part here. So now let's go plug everything into the radio and see what we got. Alright, we're back together, and no loud filter hum this time. Now let's check the voltages.
Pictures all over the internet, right here.
Alright, I'm still running 1.3 volts. I figured that would have gone up a little bit with those new capacitors, but I guess not.
Yesterday is a cap issue. He just can't.
And that will probably be okay as long as we don't try to use a radio with weak tubes.
They didn't make the rules, but I guess to do certain stuff, to work and all that, I guess you don't own your body. That's what it comes down to. If you want to work in society today, then I guess they make the rules of what goes in your body and what you do. And hopefully there's a lot of people out there that are, stronger than me and keep fighting and, have what they believe, and hopefully it works out.
I don't, am I missing it here? I get the I don't control my body thing, but the truth is, you never truly completely controlled your body in terms of vaccination and inoculations.
Well,
you went to the University of Kansas.
I could offer my opinion about that, but as I understand it, YouTube is now taking down videos and blacklisting people who offer an opinion on that subject that differs from the powers that be, and that's just really a scary thought, because that's just one step away of more of your freedoms being taken away. You've got people in power that, as long as you agree with them, and it's okay to be outspoken about it, but if you don't agree with them, then you must shut up, and that's just a step towards moving this country towards communism.
Obviously players.
Alright, we've been on about 30 minutes. Our voltages are remaining stable. 1.36 for the heaters and 100 volts for the B+, so that tells us the selenium rectifiers are not crapping out after they get hot. So, and yeah, that B+ voltage could vary from one radio to the next, depending on how much load the radio is placing on the power supply. So 100 volts for a little 4-tube set, that's a good That's a good starting point. Okay, I have some silicon diodes temporarily tacked across the low voltage rectifier, and that brings us up to 1.8 volts. Now, that's a good little margin of safety there, because you got to keep in mind this was rated for 1.4 volts output back when the line voltage was still around 110 volts. So now that our line voltage is in the 120 to 125 range, and we're only getting 1.3 volts out, and if for some reason the line voltage drops, that voltage could very well drop to a level that would prevent the set from operating. So I may just go ahead and tack these diodes in permanently. Now normally I wouldn't just tack a couple of diodes across a selenium rectifier, but this is a low voltage rectifier. I don't foresee it ever shorting. It'll just get weak, but I don't think it'll ever short, so I think we're safe in attaching these rectifiers in parallel with it and being done with it. Here are our two rectifiers more neatly soldered in place. Okay, we've got 1.8 volts filament voltage with 123 volts AC coming in from the power line. So, yeah, had we left this old rectifier in place and had the voltage drop down, the AC drop down, then our filament supply would have probably dropped down enough to cause the tubes not to conduct. Alright, I went ahead and replaced the power cord because the other one had a couple little iffy spots on it. Yeah, would have used a brown or black cord, but the audio fools tell us that AM radio reception is better when you use a white cord on your radio power supply, so that's what we did. Alright, here we are back together. Now, yes, I have 2 or 3 more of these types of battery eliminators kicking around, but I've also got a number of these battery-operated farm radios, so it's best to have a fair amount of power supplies on hand in case I want to use the radios. I can more readily do so. Alright, there you go. That's it for now, and if anything new transpires on the CD player, then we will do another video on it. If not, then we won't do another video on it.